We are going to be talking initially about spreadsheets. We're going to look at a spreadsheet that has three different options in my story problem. When we look at a spreadsheet or table, and as I said, you can do it by computer for your project using Excel or Google Sheets, or you can hand make a table. Does it matter? No. But that table or spreadsheet is known as a numerical approach because we call it running the numbers. We also are going to be facing with what they call the better buy, and that's when you pay less for an item. And then we're going to introduce you to a second story problem that is going to present only two plans, and we're going to look at the break-even point, which is the same cost that the item will cost when I purchase a certain number of items. Now, we're going to look at the first story problem. Now, this is a spreadsheet that I have done for you, but you can also see this particular spreadsheet on page 323 in your textbook. Now, the story problem is saying Nate's wife recently had triplets. Knowing that diapers are going to be part of their lives for a few years, he looks into three options for buying them. Now, the bullets that are here are my three options. Now, what's nice about this course is we're only going to deal with two options. As you go further in math, 3, 4, 5, 6 options, that should be no trouble. But you need to get the basics. So we're going to show you the spreadsheet that was created for these three bullets. It says a jumbo box of a brand of diapers that Nate likes is going to cost $30 in town and 6% sales tax. This is my first option. Now remember, when we talk about sales tax, we're talking about a multiplier of 1.06. This percent you have to equate to a decimal. We also have another store in town nearby. In a town nearby, he can buy the same jumbo box, but notice my options this time. He is going to spend $26 with a 7.5% sales tax. Now, he also has a third option. That third option is going online. He can buy a jumbo box for $25 with no sales tax, but a flat $8.50 shipping cost if he buys one or more boxes. Now, the table here is just teaching you how to read it. It is saying, using the table in the next slide, determine which option is best. Now, they sometimes say, instead of the phrase, which option is best, determine by running the numbers, finding the better buy, and how many boxes of diapers are going to be purchased. Now, this particular running the numbers is not going to be a sole number. It is going to be a sentence answer. And you're going to see when we look at the next table. Now again, this table is on page 323 in your textbook. Now, It says, by using this numerical approach, running the numbers in a spreadsheet, okay, which option should Nate choose? Well, this is where you have to go row by row to determine which column has the lower amount. The lower amount is our best buy. Well, if we look at the first row, notice that in column 2, $27 is my cheap, $27.95 is the cheapest of my 3 numbers in row 1. Row 2, notice the cheapest is in my second column. But when I go and buy 3 or more boxes, notice that my online option is always going to be the cheaper amount. Now, to answer this question, we have to have sentences. So read the sentences very carefully. If Nate needs only 1 or 2 boxes, store 2 is the cheaper place to go. That takes care of row 1 and row 2, but we got all those other rows. If Nate buys 3 or more boxes at one time, the online store is the cheapest option. So it's not just a number, it's a sentence. So when you look at something like this in Pearson, read each option carefully. Now, we're going to introduce you to the algebraic approach. Now, this approach is going to show you when 2 plans, and we're only going to look at 2, when 2 plans are the same cost. This is my break-even point. Notice vocabulary. Break-even is when my 2 plans have the same cost. Now, the fastest way, and that's always very nice to know, the fastest way to find the exact break-even point is to use the algebraic approach. To determine when 2 cost plans have the same cost, we are going to set the expressions for the cost equal to each other and solve the resulting equation. Now, we're going to look at this story problem. Now, this says consumers often shop around for the lowest gas price. Some gas stations offer per gallon discounts. And notice a discount is going against the count, which means I'm going to be subtracting those discounts with the purchase of a car wash. Now, suppose your local gas station offers a 20-cent. Now, that slash means per gallon, per 1 gallon discount in a car wash is purchased, and another 10 cents per gallon discount when using a credit card. The current price of gas is $2.35 per gallon, and I sure wish it had gone back to $2.35. And the car wash costs $8. Now, assuming you use, and this is a catch, both discounts, both discounts. When is it worth to buy the car wash just to get, and here they say, the better price of gas? Well, this is going to give you equations, and we need those. This says write equations to calculate. Now, total cost is going to be the letter C, and G is going to be the number of gallons. Now notice I have two options to write the equation. Well, remember, we have a form that says y equals mx plus b. Well, we're using this form, but with a little twist. This y is going to represent the cost. So we're changing this y to the value of C. And we also are talking about gallons per gas, the cost per gallons, which means this G is going to replace our X. So this will be a slope G. G is going to represent the gallons. But don't forget, M equals rate, or per amount. So let's look at A. Without a car wash, C is going to equal $2.35 per, that's what that M is going to represent, per gallon. This phrasing is how I write this one. $2.35 per gallon. Now, notice for the B part, I need to take both discounts. Well, my cost is going to be taking the $2.35, but we're going to subtract a 20-cent per gallon tax, or 20% discount, or 20-cent discount, and a 10-cent discount, which means I'm subtracting 30 cents with those discounts. This will give me $2.05 is what I'm paying per gallon of gas. But don't forget, I have to add the car wash. Car wash isn't free. The gas is what's getting the discount because I'm paying that $8 for the gas. These are my two equations. Now, on my next slide, we are going to see a numeric approach, but I'm also going to carry these two equations over to slide 7. Well, what was the cost? Okay, notice here in blue, the cost without a car wash was, in this case, C is equal to $2.35 G, and the cost with the, it should say, car wash and discounts is $2.05. and 5 cents, it should say car wash and discounts, is $2.05 G plus $8. Now, I'm writing those equations here because look at what the question is asking. It is asking me to use this table to estimate for what number of gallons of gasoline the two options have the same cost. Well, they're wanting me to estimate the break-even point. Well, look at the column A. These are the gallons. If you'll notice, they're going up by 2. So therefore, I need to find where is column B and column C close together. That's how I find a break-even point in 2 columns. Now 3, it's a little harder. That's why we're only running numbers for 3 columns. We're not looking at estimating anything just yet. When you go further into mathematics, you're going to do what we're going to do today with 3, 4, 5, many more columns. But we're going to teach you the skill of estimating. And you want to look, where are the 2 rows? Where is column B and C closest together? Well, if you look at row 1, we have 0 and we have $8. Well, they're $8 apart. Can I get as close together as possible? Well, if I look all the way down the columns, I am going to find that I have right here between row 15 and row 16, look at the difference in costs. I have in row B $61.10. In row C, I have $61.30. In row 15, I have a 20-cent difference. Oh, I'm real close. I am really close in this column. Well, when I go down to the 28, I have $65.80 in row B. I have $65.40 in row C. Well, notice this is a 40-cent difference. Okay. We're as close as we're going to get. So my estimate, since I'm using the table that is going by 2s, I am going to say between 26 and 28 gallons of gas is my best option when I estimate. Okay? But we want to find the exact number of gallons of gas that we are going to have the break-even point, the same cost. Well, to do that, we have got to go to the algebra approach to find the exact break-even point. We are going to use our 2 equations. Well, if you remember, the 2 equations said C is equal to $2.35 G, and then we had C is equal to $2.05 G plus $8. Now, Notice that both of these equations have the letter C. If they're both equal to C, I can now take $2.35 G and set it equal to $2.05 G plus, now I'm going to put $8, the decimal here. I ran out of space up above, so I'm putting the decimals there. Well, this is where our lovely algebra comes in. We are going to subtract $2.05 from both sides. This is going to cancel. Now, I am going to get 30 cents is equal to $8. Now, when I divide both sides by 0.30, I am going to get G. Where is my break-even point? Well, notice I will get the decimal 26.66666 or 27 gallons is the whole number where my break-even point is going to occur. Exactly, it is 26.67, 26 2/3 gallons of gas. But sometimes you have to buy a whole. That's why it may round up to 27. This is my algebraic approach to find the exact break-even approach. Now, notice here, we're going to expand on our problem here. This is saying the same story problem we have here, but it's saying which option is okay, less expensive for 9 gallons and by how much? Well, this is where we have to do the algebra. We have these two equations. That said, C is equal to 2.35 G and C is equal to 2.05 G plus 8. We want 9 gallons, which means we're going to take both of these equations, and where this G is, we're going to put the number 9. So if I take C is equal to 2.35 times 9, I am going to get, pulling out my lovely calculator here, 2.35 times 9 means I am going to spend $21.15 for gas for 9 gallons. But if I take C equals 2.09 times 9 gallons plus the car wash, this is 2.05 times 9 plus 8, I am going to get a cost of $26.45. Now, right away, what's less expensive? The less expensive is not purchasing the car wash. This is the least expensive. Now, by how much means that I am going to take the difference, $26.45 minus $21.15, gives me $5.30 difference. Okay? Now, notice we had to use both equations to get the answer for C. You needed the algebraic approach. Because if you look at that table of values, I don't have odd numbered gallons in my table. I only have, if you look at column A, they were done by twos. Well, now it says, why might the most expensive option be a choice? Okay. Now, the most expensive option can be a good choice if I want a car wash and I plan to use my credit card. The least expensive has no car wash, but why would the more expensive be a choice? I need the car wash. I need it, or I want it, okay? And also another option is, I'm going to use a credit card. I don't have cash. So these are sentence answers for D. Okay. Now, we have a couple more slides, and let's take a look. We took these two equations, and if you look in your textbook on page 322, you're going to see this graph, because we're also going to be asked a couple of questions. Now, first off, you want to find this break-even point, which is right here. This is my break-even point. Now, the key is, what were the number of gallons that I have a break-even point for? Well, this was 26.66 gallons. Okay. And remember, this is called the break-even point. Now, when you look at your choices here, they're either going to give you the numbers 26.66 or 26 2/3 gallons, or they're going to use the word break-even point. Now, it's saying also that you have, without gas, that is this yellow line. With gas is this green line. Now it's reading this graph because it is asking you in A, when is the plan without the car wash, which is the yellow line, less expensive? Less expensive. Well, where is the yellow line expensive? Well, where is the yellow line below the green line? Where is the yellow line below the green line? Well, that's the answer to question A. Where is the yellow line below the green line? Well, take a look. It happens to be right down here, which means the answer to this question is without a car wash, we have a less expensive purchase when gas is below the break-even point. So anything below the break-even point is where my prices are going to be less. But then look at B. When is the plan with the car wash is least expensive for? Well, this is saying when is the, or where is the green line below the yellow line? Because the green line is the car wash. The green line is the car wash. And where is it below the yellow line? It is below right down here. Okay, so the answer is with the car wash and discounts, we have a least expensive purchase when we buy more gasoline above the break-even point, more than 26.66 gallons. That's how we read this table. You gotta watch. If you need highlighters, use them. If you can see it without the highlighters, great. Now, we're going to summarize everything. The numerical approach helps us to see the cost of each plan for a particular volume of gas and determine the better option using a spreadsheet. The algebraic approach provides the break-even point, the exact break-even point. You can't get it by running the numbers. You've got to do the algebra. And then the graphic approach helps us analyze each option based upon the break-even point. Now, knowing these terms, you have two story problems, and it's understanding what the story problems are asking you. Now, it says the cost equation for a company to install X square feet of brick pathway is C equals $625 plus $25 per square foot. Per square foot is that 25x. And the cost equation for a second company to install X square feet of brick pathway is cost is equal to $50 per square foot. Now, they are asking you here, what is the area of the path that could be built by either company for the same cost? This is asking you to find the break-even point, because you want to know exactly. Well, that means we're taking this equation right here, and we're taking this equation right here, and notice they're both C's. So I am going to say $625 plus 25x is equal to 50x. This is how I'm going to get my break-even point. Well, if I subtract 25x from both sides, I get 25x here, divide by 25. Now x is equal to 25 square feet. Square feet. That's the area of the path that both companies are going to cost me the same. But they ask me, how much will it cost? Well, you have a choice, but you're going to get the same answer. If you put $25 in and solve this expression, you will get the same number if you put 25 here for x. Well, let's show you. If I take 625 plus 25 times 25, this will equal, in this case, $1,250. But if I take 50 times 25, I am still getting $1,250. It doesn't matter which equation. I know what x is. And since they're both the same, they've both got to tell me that it's going to cost me $1,250. That's my cost. Now, the last one. This is going to take a little bit here, okay? Because this is where you have to remember better buy, okay? Better buy equals cost divided by quantity. And that's most important. One grocery store charges $8.50 for 8 cans of soup. A second store charges $5 for 4 cans of soup. But you need to join a purchase club for $25 to buy them. Now, it's asking me to write the cost model for both stores and find the number of cans that will make the cost equal. Well, remember, cost equal is my break-even point. So therefore, let's go for it. The grocery store 1 has the equation. Now, this is where you have to remember. This is cost divided by quantity, which means I am taking $8 and dividing it by 5 times x. Well, if I take $8 and divide by 5, I am going to get $1.60 x. This is my cost equation for grocery store 1. Now, grocery store 2 has this equation. It is saying that I am going to take $5 for 4 cans X, but I've got to add that club price. Well, write this as $1.25 X plus 25. This is my second cost equation. Well, as you see, this is a C, this is a C. So I now write $1.60 X is equal to $1.25 X plus 25. Now, I'm subtracting $1.25 from both sides. This will give me 0.35 X is equal to 25. Now notice I put the dollars on these because I kind of ran out of space up here. But this is money. Money is 2 decimals. When I divide by 0.35, now notice what I'm going to get. The exact amount is going to be, is going to be 70, is going to be 71.43 cans of soup. Well, I need this decimal because I want to find the number of cans. That's right here. 71.43 cans is when my cost will be exactly the same. Okay. Or, notice, I could also say between 71 and 72 cans. That is also how they're going to tell you. Now, this is the end of 3.6. Hope you enjoyed it.